Hi, everybody. By request, I'm going to start working on some science videos. I've done a lot of math videos, all the review videos in the grade 11 and most of the grade 12. I haven't done a whole lot in science. So I thought I would start today on pedigree. So this is genetics, part 2. Usually, sometimes it's the end of part 1. I don't know. Part 2. And we started out talking about pedigrees this morning. Now, pedigree, I don't know about you, but when I hear pedigree, I think dog food. That's the absolute truth here. But really, a pedigree, in this case, is just a family tree. And very specifically, it not only shows relationships like mom and dad and grandparents and kids and all of that, but it also usually follows a trait through the generations. That's how the genetic works into it. All right, so the basics are, that's a male. And that's a female. If I do this, that's a marriage. And if I do this, those are children. So this could be just a generic family tree. So here are the two parents, mom and dad, and they had a girl and a boy and a girl. When we want to start talking about traits, normally what we would do is shade in. So if whatever the trait is, if this child had it, and maybe dad had it, I don't know what the trait is, so I'm just randomly coloring stuff. There we go. Okay. So normally there'd be a key. And this would say trait. So maybe it's brown hair or blue eyes or Huntington's disease or lactose intolerance. I don't know. Trait. Not trait. I tend to use normal, and I probably shouldn't be. And the other thing that usually goes with this is there would be some kind of a instruction. Say, let's just say this is a pedigree of brown hair. Okay, so dad has brown hair and the two kids have brown hair. And to make life simple, we'll say that mom and the one daughter are blonde. Ta-da! That's a pedigree. What scientists use these for is, say there's a trait, lactose intolerance, okay? Nobody really does a trait of who has brown hair in a family. It's not that important. But let's say lactose intolerance, and they would go through, they would talk to the family, and they might go back as far as many generations as they know in the family tree. And then they would say, okay, well, who is lactose intolerant, can't handle milk? Who can handle milk? And then from that, they can determine the inheritance pattern of that disease. So that's where we're going with this. So we have 3 choices. Okay, so our pedigrees are going to be one of 3 things. They are going to be autosomal dominant. Oopsie, tried to write both words at the same time. Autosomal dominant. And actually the example right here is an autosomal dominant one, because every child that has it, one of the parents has it. I wouldn't make important life decisions based on my genetic skills, but for the simple stuff we need in grade 12, this will do. So the key there, if child has it, has whatever the trait is, at least one of the parents has it. So if you start on the children and you go up a generation, either mom or dad or both will have that trait. The other two are recessive. So this is number one. Number two, let's go autosomal recessive. I'm going to try and squish all of these on the same line. And you know from before, autosomal recessive means you need 2 copies of the gene for it to show up. So I'm going to draw you the most simple pedigree I can. There's mom, there's dad, and the kid has the trait. So maybe mom has brown hair, dad has brown hair, baby has blonde hair. Now notice I switched to this, so there would have to be instructions telling you what all this stuff stands for. Okay, but with recessive, what you're looking for right there is that pattern where the parents don't have it, don't have the trait, but the child does. And the third one is X-linked recessive. And it's going to look, you're going to start out by looking for this part. But once you have determined that it's recessive, because really this mom and dad don't and baby does, is just recessive. With an X-linked, and I'll have to show you some examples because I don't want to draw a great big one. Being honest with you. Mom and dad don't have it, but if you remember from before, oh, let's give these guys a bunch of kids. Daughter, son, son. So the pattern is the same as before. So parents don't have it, kids do, but mostly males have the trait. And when we're going through these on a test or something, I'll make sure it's really obvious. So this one, you might have all girls or about 50-50 split with boys and girls. On an X-linked recessive, I would pretty much make sure it's almost all boys, maybe one girl thrown in there. Okay. Again, some of these I'm going to make up just for our exams. All right. I think that's enough for now for this. I'm going to get out the big sheet that everybody has, and you can get a copy of it from me if you want. And we're going to do some analysis of patterns, and then we're going to come back and we're going to look at genotypes because we can do both. All right. Whoop. Hold on. Wanted enough room so I could write properly on here. So yours probably doesn't say pedigree of blue eyes on it. I just started adding stuff so it makes more sense. So how do I know whether it's autosomal dominant, autosomal recessive, or X-linked? Well, you start with the afflicted children. And you can see on here that this girl and this female both have that trait. But my magic, hold on. Is to look at her parents. So anytime, how's that showing up on there? Nope, don't like it. 1 minute. Lovely. Let's try again. There is an example of mom and dad don't have the trait and the daughter does. So right away, I know it's going to be one of these two. It's a recessive trait because basically it's been hidden. It's been masked by the dominant trait here, and it shows up here. The fact that down here, this mother had it and I don't care. I mean, I do care, but I don't. Not when I'm determining it. All I need is one instant where it's the two parents don't have it and the daughter does, or the child does. Now, because these are both girls, I'm going to say this is autosomal recessive. If those were both good boys, I probably would have said it's X-linked. Now, I said this is a pedigree for blue eyes. And so these two girls have blue eyes. And we're going to use a dominant trait of brown eyes. So watch, careful. Even though my whole trait, sorry, that's just something on the paper. My whole thing is about blue eyes. It's still a recessive trait, so it gets the lowercase. So here are my possible genes. Now we need to look at, I think I'm going to do all the work on each one. We're going to look at genotypes. So my possible genotypes, blue eyes. Sorry. Oh, now I put it behind my, there we go. I can have the heterozygous version, which is going to be brown eyes. And here's the rule. On these forms, you can never, ever have homozygous dominant because you can't tell from a pedigree what this person is. Okay. But they do have brown eyes. Now, if that doesn't make sense, just trust me for right now. So let's do the easy stuff. On here, we have two individuals that have blue eyes, and there's only one genotype for blue. So we're going to do that. Right? Those are the ones with blue eyes. Everybody else on the whole chart doesn't have blue eyes. So that means everybody else, whoops, I'm sorry, it's been a while since I've done these, has brown eyes. And I know if they have brown eyes, they have at least one gene for brown. So I'm just going to mark them all. Now my genotype needs 2 letters. Oh, look, I can write small enough that they go in the boxes. My genotype's always going to have 2 letters, but I know all of these guys, whoopsies, this one too, have brown eyes. So they must have the 1 gene. So now the trick is to go back and figure out whether they are the heterozygous, so whether it's like this, or whether we can't tell for sure. And let's start with our blue people. Okay. Let's start here with this daughter. If we go back, she's got blue eyes. One of these came from mom. So this, whoops, that didn't work well. So that B came from mom. The other B must have come from dad. So we can say with certainty that dad was heterozygous. And you know what? If we go up another generation to, okay, that's mom and dad's, grandpa and grandma, for this girl to be blue-eyed, that those little B's, those recessive genes, must have come from up there. Cool, right? We can trace that back. Now, all these other family members, I don't know. All we know is they have brown eyes. Because let's look specifically at individual number 5 here in generation number 2. He got this gene, or this gene. I don't know who gave it to him, but one of his parents gave him the capital B gene. But we don't know what the second one is. It could be 2 capital B's, or he could be capital B, little b. So he could be homozygous dominant, or he could be heterozygous, sorry. But we wouldn't know until he has some children. And that's the trick. We could do this part over here because we had children with blue eyes. Until somebody in all of this area has some kids with blue eyes, we can't make any decisions. So they're all going to get, we're not sure. If, for example, this individual down here, this son, had blue eyes, we'd be able to trace back that these 2 parents were heterozygous, but it's not, so we don't know. And ta-da, that's pretty much all we can do on this one. Oh, I guess the other choice for finding out the genotypes is not only if these have children, but if we were able to travel further up this way. So if these are the grandparents, the great grandparents, or in other generations up that way, then we could have some idea. Maybe there's a blue-eyed person in there and we'd be able to work it out. All right, I'm going to do one more. And then I think I'm going to stop the video and start a new one. Okay, so this one is freckles. So I always start with the children, and I go up a generation, and I see, in this case, twin boys, right? That's what that means. Mom had the trait, and if we go up again, grandpa had the trait. So every child that has the trait has a parent that has it. So that's enough for what we're doing to say this is autosomal dominant. So since I said it's a pedigree of freckles, we're going to use capital F for freckles and little f or no freckles? So then our genotypes, I'm going to put them over here. We can have 2 little F's, and that's going to be no freckles. We can have the heterozygous. Oh, my bad. Doing the other question. Start over. Try again. F little f. That's going to be freckles. Right? Heterozygous. And again, our other option is F with the blank. It's also going to be freckles. You can never have the 2 capital letters. It just doesn't work that way. So everybody who's colored in has freckles. So we know everybody needs this gene. Excuse me. So like before, yep, you can see that. Now notice the difference in this one, because it was autosomal recessive, we gave the 2 little letters, okay? 2 lowercase showing the recessive traits. This one, the colored in ones are the dominant traits. So we get to put the capital letters. And we're gonna go back afterwards and figure out whether they are the heterozygous or this one. But I just want to do the easy stuff first. Every one of these people who is not colored in, so all of these, that one, everybody, those have no freckles. And no freckles only has 1 possible genotype. So go ahead. Every single one of those. Look, we're done 3/4 of it. Didn't even have to think very much. Now we do have to think. So let's start down here. I don't know. For me, it works better to start at the bottom. So we've got these 2 twin boys. If we go up and look at their parents, they got the freckle gene from over here. But if we look at their dad didn't have freckles. So the only possible gene he can contribute is the recessive gene, the one for no freckles. So we know their genotype. Now, if we look at mom over here, okay, mom and dad created 2 daughters that have no freckles. So mom was not a pure freckle. She was heterozygous because we need this one here and one of the ones from dad to give you those. So that's not bad. Let's go up to individual number 3. Okay, I'm going to stop for a minute. I want you to think and possibly even be brave enough to fill it in on your sheet. And if you're not brave enough, then use a pencil. All right, let's look at what happens with the kids. We have kids, we got freckle. So that makes sense because freckle from dad, freckle down here. But there's a son and some daughters here that didn't have freckles. So one of those F's came from mama. The other one must have come from papa. And we have some way over here, individual number 1. If we look at all of their kids, no freckles. So what do we know about dad? Exactly. He also is heterozygous. So some maps, or sorry, some pedigrees, you can determine you can figure out the exact genotype on everybody. Whereas this one up here, No such luck. This whole section over here, we couldn't tell. All right, so I'm gonna say that this was genotype video, or sorry, pedigree video number 1. And I'm gonna end it because I'm gonna make pedigree video number 2. Have a lovely evening and hopefully you're gonna come right back.